So I don't know if you guys remember, but on Friday we did the quizzes, and then we started on 2x2 matrix multiplication. We did delta math, and you didn't have to complete it. It was just more like try this out, see if you can figure out the pattern. Today we're going to be doing matrix multiplication, but we're going to be changing from just 2x2 to any number of different dimensions. So we could have like a 2x3 and a 2x4, all kinds of different things. We're going to first of all determine if we can multiply, and then if we can, how we're going to do matrix multiplication. So let's dive into that. You will want to write some of this down. You also need your computer because we're going to be answering several questions here in a minute. So before we go over how we're going to multiply, we first need to figure out, can we multiply? Can we multiply two given matrices? So let's start with an example. What if I took the two matrices we had in our warm-up problem, these two matrices, and we can definitely add them together, right? We can add A plus B. But the question is, could I do A times B? Could I multiply those? So let's think back to Friday. You guys did matrices multiplication, just a little bit with 2x2 matrices. You did it 2x2 times a 2x2. Do you think this would work? A times B. Or could I do B times A? Will those possibly work? What do you think? So yeah. Anybody else? This will not actually work. This is actually a no. This is not defined. And I'll explain why here. So when we're determining if something can be multiplied, how we determine that is we say that the inner dimensions must be the same. And I'll explain what that inner dimensions term means here. But we say the inner dimensions must be the same. So when I write out two matrices, let's say I take that and a warm-up question, what are the dimensions of these two matrices? What's the dimensions of these two? Yeah, they're both 1x3s, right? So if I have a 1x3, then I'm going to multiply that by a 1x3. The inner dimensions are these two numbers in the middle here. These are called the inner dimensions. It's important that you put them in the right order as well. So those are the inner dimensions. Those must be the same. If they're not the same, this would be not defined. We're going to practice this a lot, so don't worry if you don't get this example written down. Right? Now if they are the same, so let's change this up. Let's say instead of a 1x3 and a 1x3, what if I did a 3x1 and a 1x3? So if you look at the two middle numbers, these are your inner dimensions, they're the same, so we can actually do this. This will work. Now, our answer, anybody have a guess what the dimensions would be of our answer? So the answer is actually going to be the outer dimensions. So these are called the outer dimensions. And that is going to be what our answer is. Our answer is going to be a 3x3 matrix. So we say the resultant, that just means the answer in matrix terms. The resultant will have the outer dimensions. So answer is going to be a 3x3 matrix. They have to be the same in the middle. If they are the same, then our answer is going to be the outer dimensions. That will be the dimensions of our answer. 3x3. When we did it on Friday on those delta maths, they were all 2x2s times 2x2s. And that will always work if you do a 2x2 times a 2x2, because, well, those are the same, they're both 2. And then our answer was always a 2x2. So that was kind of a simplified version. where you didn't have to worry about if they work or not. Because if you have two square matrices that are exactly the same, then it's always going to work out. All right, so we're going to do a bunch of practice here. So you will need your computer there. And you might want to write out the dimensions for each of these. We're going to go through, I think there's 5 examples. So I want you to choose what is the correct, all of them should be multiple choice. And again, you might want to write out the dimensions. Make sure you write them in the correct order. This is 2 rows, 1 column. So this is a 2 by 1. This one is just a single number, so it's a 1 by 1 matrix. The inner dimensions would be 1 and 1. Those are the same. It works. So then their answer is going to be these outer dimensions. So that's what you want to select. You want to select yes and be a 2 by 1 matrix. All right, for the next one, I won't give you any help on this one. So determine what those 2 dimensions are going to be. Don't try to write down all the numbers here. You can write out the dimensions if you want to, but don't try to copy those matrices. Think about what the dimensions are here. I'd write them out here. See what we got here. Alright, so kind of split here. It's like the majority are going not defined. Let's see if we can figure out why. So this one is a 3 rows, 4 columns. 3 by 4. This one is a 3 by 3. These are not the same, right? So this would be not defined. So look at the 2 inner ones. These are not the same, so we don't have to worry about the answer. It's just not defined. Let's try this one. Now these two, when you just look at them, it seems like, well, there's no way you should probably be able to multiply those because they don't look anything like each other. But when you actually write out the dimensions, we got a 4 rows, 3 columns, 3 rows, 1 column. So they actually are the same in the middle, and the answer would be a 4 by 1. Yeah. Where's that? Okay, I got 2 more here. So we got a 3 by 1 and a 3 by 1. 3 by 1 and 3 by 1 don't work because the inner dimensions would be a 1 and a 3. So that would be not defined. And last one. All right, we got a 5 by 2 and a 5 by 2. So that's it. Very good. You guys got the... I guess I got one more, sorry. Last one. Bless you. So we got a 3 by 5 and a 5 by 5. So the middles would both be 5 and the outer would be 3 by 5. Okay, enough of that. Let's go ahead and actually try to do this now. So we're going to go through the matrix multiplication. I'm going to go through and do an example, and then if you like sort of steps written out in words, I'll do some of those after we do this example. But it would be a good idea to write down at least one of these, so you can have an example of what we're doing. They change, each one changes just a little bit depending on what the matrices look like. But the general pattern is the same for all of these. So it follows a similar pattern if you can remember when we did 2x2s on Friday. So we're going to do A times C. There's our two matrices. All right, so first thing we need to do is figure out if this is something we can actually do. Will this even work? We don't want to spend time trying to do something that's not even going to be an answer. So we want to go ahead and write out our dimensions. So 2x3. This one is 3 rows, 2 columns. And our dimensions agree, are the same. So then our answer is going to be these outer dimensions. It's also a good idea to write out those outer dimensions, 2x2. So that we know when we're doing our matrix, we know kind of how it's going to set up. We know how many spaces we need to leave and all that stuff. So it's definitely a good idea to write what our answer should be. It should be a 2x2 matrix. All right, so I'm just going to draw a bracket. Let's do a big bracket here. And I'm not going to close it off because I don't know how much space this is going to take. And here's our just general technique strategy. The first letter is A, so we're going to start in matrix A. And we're going to do this first row. So always the row of the first one times the column, the first column of the second one. So imagine that first row times first column. Row in the first one, column in the second one. And then each of these is going to have a number that it matches up with. So 0 and 4 are both in the first position. So it's going to be 0 times 4, like that, plus match up the second ones. 3 and 6 match up. So 3 times 6. -5 and -2 match up. So plus -5 times -2. And that's going to be our first entry, our first element there in your matrix. So we did first row, first column. Each of them matched up. As we go over this row, we go down on this column. So now the next one is going to be still first row, but times this second column. First row, second column. And that's going to go over here. So these two kind of meet in the corner, so it's going to be this one. So it's going to be 0 times 1, because they match up, plus 3 times 2, plus -5 times 3. All right, so first row, first column, first row, second column. If there had been a third column, we would then do first row, third column. But we're out of columns. Since we ran out of columns, we're going to drop down now to the second row. Close this off. This is going to be my end. So now I drop down to my second row, and I'm going to repeat that process. So I'm going to do second row, first column. Match them up. We got 1 times 4 plus 2 times 6 plus 6 times -2. And then I got one more. I got to do my second row times second column. So I'll do 1 times 1 plus 2 times 2 plus 6 times 3. And there we go. So there's a lot of multiplication, a lot of adding. Generally, they'll all be small numbers, so it's not like incredibly hard, but You can see how if you make one little mistake with the sign or something, it could actually give you the wrong answer. We're not going to do this on delta math for that reason, because if you mess up one sign, you do all this work and then you miss the problem. It's pretty frustrating. So they're all day and do this. I get it. All right, so let's go ahead and simplify these. After you get the hang of this, you can skip this middle step if you're good with mental math especially, but I'm going to write it out. So here we've got 0 times 4 is 0, 3 times 6 is 18, so plus 18, and then negative 2 and negative 5 is 10, so plus 10. Next one, we add these up. 0 times 1 is 0, plus 2 times 3 is 6, plus negative 15. Done on blue. 1 times 4 is 4. 2 times 6 is 12. 6 and negative 2 is negative 12. And last, 1 times 1 is 1. 2 is 4. 3. And now we can add those up. But again, you can skip this step if you want to, if you just want to either type that in or if you can just do this in your head. Sometimes what I'll do, I'll just write above it real small, 0, 18, and 10, and then just add those up. So however you want to do it. But I just want to show you the long way here first. So then that becomes 28. 6 and negative 13 is negative 9. These 12 cancel, which is 4. And 23. So that is our answer. It's 2 by 10 meters. 28, negative 9, 4, and 23. Also, something to notice when you're doing this that will help you check your work. If you look in this first one that we did, look at the pattern that you'll see here. 4 and 4 line up. 6 and 6 line up. Negative 2 and negative 2 line up. 1 and 1. 2 and 2. 3 and 3. So you can kind of try to be precise and like write them underneath of each other. It's a good way to check your work. See how this always matches, so you can see if you made a mistake. Also, zeros are in the same position. 3s are in the same position. Negative 5 is in the same position. 1s, 2s, 6s. So it's a good idea to just check that to double check before you add, and you can do that as well. Just make sure you see that pattern going throughout there. And we should be good if we added everything correctly. So that is our answer. Yeah, that's fine. Yeah. All right. So if you like words describing what we're doing, here's some words. You don't have to write them down, but if you like it, here's a description, a verbal description. So that's helpful to you. So how are we actually doing this? There's not a great way to describe it, but here's the best way that I know how as math description. We multiply each row in the first matrix. So the first matrix, we're always doing rows. Right, each row in the first matrix times each column in the second matrix. So each row in the first, and then go down to each column, go down to the next row, times each column. And within that, we're going to be finding the sum of each of these. So each one, we're finding the sum of each of these elements. So we multiply and then sum for each element. So the first matrix, whatever one comes first in the problem, is always going to be rows and then times the columns of the second one. Rows in the first times the columns in the second. Once you get the hang of it, it's really just doing the same technique over and over again. Yeah.
If you were to do the other way, second matrix, would it change it?
That's a good question. Yeah, that's going to be our next slide. Yeah, very good. Yeah, so that was actually the next question I was going to ask you. Is if we do the same problem, everybody got this? Okay. If we do the same exact problem, let's see. Let's switch it. We did, let me just double check it. We did A times B, right? A times C. All right, so we're going to do C times A. This one. So same problem, except we're going to switch the order. So the question is A times C equal to C times A? Yeah, so we talked about this just a little bit on Friday. We talked about how like 3 plus 5 equals 5 plus 3, right? And also 3 times 5 equals 5 times 3. It's called the commutative property. Now with matrices, it seems like this would work, right? It seems like A plus B does equal B plus A. We're adding them. If you were to look at the original example, it wouldn't have mattered the order that we added these to. If we had done this in reverse, if we switched the spots, we would get the same answer when we add them. The thing is with multiplying matrices, and again, I think I mentioned this maybe on Friday, is it is not commutative. So it seems like it should work the same. It seems like A times B should equal B times A because one multiplication is commutative, but they're actually not equal. They're not equal to each other. And let's see if we can figure out a good reason why. So multiplication matrix multiplication is not commutative. There's a really good, easy explanation why. Before we even do it, we'll do it to see that they're not the same. But let's just write out the dimensions to start. So if we're doing C times A, we need to make sure we write the C dimensions first. Okay. So the C dimensions are going to be 3 by 2, right? And then the A dimensions are 2 by 3. So make sure you get the right order. If you write them in the wrong order, then this won't work. C is written first, so we write the C dimensions first, right? A is second, so we write A dimensions. All right, so if we're going to multiply this, the inner dimensions do agree. So that means we can do it. And our answer is going to be the outer dimensions, which is a 3 by 3. Right? So already at this point, if you look back at the example A times C, if we flip back to here, what were the dimensions of our matrix we just did? Yeah, it was a 2 by 2, right? This one's a 3 by 3 when we switch the orders. So it definitely can't be equal because they're not even the same dimensions. So how can it be the same matrix? Right? It won't always be that case, but you'll never get, I shouldn't say never, there could be a scenario, but yeah, you won't get the same answer. And again, this one is easily proved because you don't even get the same matrix dimensions. So there's no way that we could get the same answer. Okay. So let's go ahead and do it and see how the answer is different. Sorry, I gotta flip back to the right slide. C times A. All right, so C times A. Now this gets a bit confusing because this is our first one. So now instead of doing this row times this column, we're actually going to start with the C rows, because that's what comes first. C is first, so we're going to do its rows times the columns in A. And also notice that this row, there's 2 in this row, and it matches 2 in this column. If you ever try to do it, and if it doesn't match the same number, then you'll know that it's not defined. Because this has 2 in the row, and this has 2 in the column, so it will work out. This is going to be a 3 by 3, so a little bit more space. All right, so we do first row times first column. That's going to be 4 times 0 plus 1 times 1. So first row times first column. Now we'll stick with the first row. Gotta go through all the columns. First row, second column. So 4 times 3 plus 1 times 2. 4 times 3, 1 and 2. Now we've got the third column, so we gotta go all the way through. First row, third column. So then 4 times -5 plus 1 times 6. And then that's all of our columns, so we can go ahead and close this off. All right, now we did all the columns, so we're going to drop down to the next row. So now we'll do second row, first column. 6 times 0 plus 2 times 1. Now we move over to the second column. 6 times 3 plus 2 times 2. Now we move over to the third column. 6 times 2 and -5 and 6. 5 plus 2 and 6. And then we got to drop down and do our third row. So now third row, first column. -2 times 0 plus 3 times 1. Move over to the next column. -2 times 3 plus 3 times 2. And then our last column, -2 times -5 and 3 and 6. Then we're finished. We want to go ahead and check and make sure everything lines up. Again, being orderly, trying to keep it in nice rows is helpful. We got zeros, ones, threes, twos, -5s, 6s. Then you can see all of these are 4, 4, 4, 1, 1, 1, 6, 6, 6, 2, 2, 2, -2, -2, -2, 3, 3, 3. So it's a good way to check before you actually do the math there. If you wanted to then just do this and skip the middle step, this one wouldn't be hard to do. We got 0, 4 times 0, 0, and 1. It's going to be 1. 4 and 3 is 12, and 2, so that's 14. -20 and 6, so that's -14. Here we got 0 and 2, it's 2. 18 and 4, 22. -30 and 12, which is -18. 0 and 3 is 3. -6 and 6 is 0. And 10 and 18 is 28. So that is right. Starting to click. I want to try what's one more, and then you guys can work on your assignment here. Let's try last one. Let's try A times B here. Is anybody done with it yet? Yeah, so this is an easy one. Before you do any work, what you want to check, and maybe we'll just switch them around and try it. If you do your dimensions here, and you can start to look even maybe without it writing the dimensions. If you think about what your first row times column is going to be, it's going to be this row, right, times this column. Okay. Well, this has 3 numbers in this row, and this one only has 2 in this column. So this is not going to work because if you do this row times this column, these 2 have pairs, but the last one doesn't have a pair. So you actually can tell that way that this is not going to be defined. You can also write out the dimensions 2 rows, 3 columns, 2 rows, 3 columns, and their dimensions don't agree. So it doesn't work. What about if we switched it around, did B times A? Is that going to change anything? Yeah, it'll still be not defined. Okay. So you guys are going to do just 3 problems. You've got like 13 minutes to work on it, so hopefully you can get at least most of it done. In those 3 problems, one of them is not defined. So you're actually only going to do 2. And we'll practice some bigger ones tomorrow. But I didn't update for some reason my things don't change. See, here's your assignment. Not that far. It's just going to be 16, 18, and 20. And it's right on Google Classroom, but for whatever reason, Google Slides doesn't update when I make changes to it. So 16 to 20 evens or 16, 18 to 20. And it is on Google Classroom already. So get a start on that and try to get some of it done. I'll be around to help you too if you are confused on how to start that. But it's going to be these same A, B's, and C's, 16, 18, and 20. And like I said, one of them is not defined, so you should be able to pick that one out. Make sure if you're confused on how to start it or what you're doing, make sure to raise your hand and ask for help.